Hi and welcome to these videos on miscellaneous integration techniques. And in this video, I've got 4 examples, which I'm going to split up into 4 videos. You'll find the links on the OneNote as usual. So you can see here the success criteria is not well designed, but I think I found it quite difficult to set it up because this is just a miscellaneous set of work. It comes with a whole range of different techniques that you'll need to use. And this exercise, the equivalent one in the textbook, will be like that as well. It's actually a really good exercise for you to practice your choices, the choices that you make when you're doing your integration. So let's have a look at example 1. In example 1, I'm asking you to find the integral of sine x cos x by first substitution and then trig identity. We're going to compare our answers. So let's do it for question A. So the integral of sine x cos x. Now, it shouldn't really matter which way around I do this, but I'm going to treat this cos x as the important part here. So I'm going to let u equal cos x, which means that du dx is equal to negative sine x. I shouldn't have made that choice. Now I'm doing negatives, but anyway, it doesn't matter. And if I rearrange that 2 steps at once, I get dx is equal to negative du sine x. And so I'm going to bring that over here. That means I now have sine x times cos x, which is now u, and then I've got times dx, which is now negative du sine x. And you can see my substitutions worked because all of my x terms are going to cancel out. And so now I've got the integral of u du, but there's a negative, which I'll place out the front, a bit easier. And this, of course, is equal to negative a half u squared. I'll just pop some equal signs out here to show my step between lines. And of course, I'm going to write this down as negative a half cos squared x plus c. Put the plus c there. So I've converted it back into a function in terms of x. So there's A. Now, side by side, let's have a look at B. We're going to integrate using a trig identity. The trig identity that sine 2x is equal to 2 sine x cos x. And so I get this, the integral of sine x cos x dx is equal to the integral of a half sine 2x. So the half has come because of this 2 here. So I've halved both sides of this relationship to get rid of that 2, and I'll get a half out the front there. Dx, and this I can integrate because it's a single trig function. So I get a half, and sine integrates to negative, so let's put a times there, times negative cos 2x, but I have to divide that by 2 as well because of this 2 here, plus c. And of course this is equal to 1/4 cos 2x plus c. Now our problem is, I'll just give us a little bit more space, I'll explore this in purple, and that is that these two things are not equal, but we've just integrated the same thing. What we have here is a cos 2x term and a cos squared x term. 1/4 and a half don't really matter. Well, I should have a negative in front of that, so I've lost a negative. There's my negative. But the 1/4 and a half don't matter too much because you're going to see that, let's say I take this side, the cos 2x, I can expand this down to be 1/4 times cos squared x minus sine squared x. That's our trig identity, plus c. But of course, we want to go to just all cos squared x. So let's go to 1/4. And then this becomes cos squared x minus 1 minus cos squared x plus c, which of course is equal to negative 1/4 times 2 cos squared x minus 1 plus c, which is equal to negative 1/2 cos squared x, and then plus 1/4 plus c. And now we're closer to where we were. Okay, we have our negative 1/2 cos squared x, so we've got the same there. Our only problem is this slight issue here of 1/4 plus c and just c. And this is where we need to recognise the fact that our unknown constant is unknown. So therefore our c's in our 2 original answers in black were actually different values. The second C was a quarter less than the first C, but they're still unknown constants. So having an additional little bit of a constant there means we still essentially just have a C, and so that's fine. So there we go. You could do it either way, this question, and in your exam you may be prompted to use a certain method, but you may not, and it's important for you to be able to make a good choice there. So there's example 1.